Newtonian, I'm sorry, in classical Newtonian physics, you just set 1/2 mv squared minus g little m big M, set 1/2 little m v squared minus big G little m big M over r sub s squared equal to 0, and then set v equal to c, and I think you end up deriving that exact result right there. So what I said was you just take the sum, the kinetic energy and the potential energy, gravitational potential energy, setting those equal to 0, and for a certain radius, I guess, and so then you could calculate what the escape velocity is in that case, or rather set the escape velocity equal to this guy, and then you find out what that radius is, and then so the idea is that anything smaller than that radius, the escape velocity is greater than the speed of light. So that's essentially what happens. And once you fall inside the event horizon, the escape velocity is greater than the speed of light, and so then nothing can escape essentially, except by quantum mechanical means like this Hawking radiation and whatnot. Okay, there we go, Hawking radiation. And essentially that's a quantum mechanical effect. So there's several ways one can think about that. You could actually, let's see what time it is here. You could think of it in terms of a virtual sea that I mentioned in the vacuum particle-antiparticle pairs that are being generated right at the event horizon. One of them falls into the black hole, the other escapes outward, and so you would actually detect that as radiation coming out. And so I guess that's one way of thinking about that. Of course, there'll be some thermal distribution of this Hawking radiation. And then I guess they talked about, okay, candidates for black holes. Well, certainly we have one very, I think, clear candidate in the center of our own galaxy. There's a supermassive black hole, which is Sagittarius A, something Sagittarius, like A star Sagittarius or something like that. But anyway, so these are other galaxies, but I think as far as we know, I think the evidence suggests that every single galaxy has a supermassive black hole at its center, apparently, including our own galaxy. Brain dragging, okay. The rapid rotation can actually drag space-time, essentially. So interesting that we even have to use general relativity to make corrections for our GPS system right there. So that's the only way that you're able to get accurate info, like on your cell phone, about where your location is and so forth. If you're using Google Maps, for example. Okay, all right, well I think, let's see, what's chapter 16? I'm not going to go over it now, but just, oh, cosmology. Okay, that'll be a good one. So all that'll be for later, maybe after you turn in the exam. Okay, so I hope everybody good luck on the exam. Try to get that in on Monday so that I can give the TA enough time to grade those. And otherwise, I hope everybody has a nice weekend.